Hey everyone. In today's video, we're going to see about LangGraph and how it is actually working in backend. I know most of you would have experienced and used LangGraph. If you don't know what it is, check out my previous video where I explained what it is and how it is actually different from other frameworks. So let's start with state and memory. That is why LangGraph is different from other frameworks because it holds and manage to perform with memory. So it holds data and stores in memory, and whenever it is required, it just sends it as a next state. I mean, to the next node. So let me just quickly give an overview about it. Before that, yeah, I just refreshed from my old session. Yeah. So I'm just going to give a quick demo on this with a state and memory concept where you will see it's a simple flow diagram where you can just see the steps. The start, it gathers information, process it, and generates a result, and that's all. It's a simple process where in every application that we do, this is a flow where the process is actually your LLM when you ask anything or any questions that you wanted, it need to be answered, right? So where it is actually process it, and finally you will get the results. So how actually the state is happening in LangGraph is when I just give a start. Yes, it's a simple step. But in the background, we can see some of the nodes have been like processing it. So let me just start with the, yeah, okay. So each state have been, changed. Let me do this again so that you can see. So the process. In initial state, we just started with 0 KB. The state, which is the start of your node, you don't have any information, you just asked for it. When it gathered your information, I mean, the question it just got from you, the size is 0.2 KB. The size may differ based on your input. Here it's just a question. It may be like hello or how are you, anything it may be. So it is like 0.2 KB. When I just gave that request or question, it just started processing it. That time, the overall question along with answer is 0.4 KB, and final response is off with zero point 0.6 KB. Once the result have been shared, it still holds the memory. I mean, the question or answers or the data that you provided. So it stays. So state persisted with 0.6 KB of your data, and it stays until the next question happens. So you can just go on and check the history of it. That's how the conversation happens. And that's when the LangGraph is more efficient compared to other frameworks because it is especially built for LLMs, and other state information are node and edges. It is basically a graph, right? You can't do everything with a chain like flow. So when once you just have the root and root node and parent and child, you will have like basically the classification which just classifies your entire operation into. So node A will hold certain things and node will handle certain things. You can run multiple operations into it. But for LangGraph, it is all same, and it just classifies and make it happen with the flow the way you define it. So I want node 1 to be performed with certain operation and node 2 to be performed with certain operation. And at the end, I'll get the results. So this is the flow. So I'm just giving the conditional routing for it. If you see, conditional is basically your decision making process, and that is also happening here. When I give the input is hello, and I just gave the score is 5, and I gave a rule where it should, handle and respond back if it is less than 10. The score is less than 10 means I should get a response. So this is the condition. So when I just start, it just makes a decision and it is less than 10 and it is done. So this is how this conditional routing happens, and cycle is all of same, but it just goes on and on and on. Like the decision will be made, and once it is done, it will be like a loop until a certain point achieves. It will be like iterating at a certain level that you need to specify, like a while loop, not for loop. It is like a while loop until the condition is true. You'll be like repeatedly doing it. So yes, so same thing. Once it is done and it continues, finally the rule have been achieved or it failed, then we'll reach the end node. So this is like a simple flow thing that you can imagine of, okay, I have only less operations, and this is like I can do it in a if else loop or something else. But when you are doing like a lot of operations, handling AI agents, multi agents, that's when LangGraph is like really helpful, and you can uh, reduce the computation time of it. Computation time in the sense the entire flow. So because you can define each and every node in edge wise, you can just directly share the task between every node. Like node A and node B can handled by certain operations. Meanwhile, B and C will be handled by a certain operation, or C or D, like that. Instead of like having any connection between each other, you can have this multiple operations side by side and work with an ease. So that's when LangGraph is very useful, and it is the objective LangGraph created is for that, to handle multi-agent and meaningful stateful communication can happen using LangGraph. So that's all I have for today. I hope this video finds you well. So thanks for watching. Bye.